Hey everyone, welcome back to Gophercises. In this exercise, we're going to be trying to create a Twitter contest CLI. So what that really means is we're going to try to make a little program that you can run on the command line, and it will track who retweets a specific tweet, and will store them all in a file with unique usernames. And then after so long, if you want, you can come back and you can run this same program with maybe a different flag or something like that and tell it to pick a winner based off of that list of usernames. So your traditional contest on Twitter is probably going to be something where you tweet some message like, you're releasing some new widget or something, and everybody who retweets it can sign up for a chance to get a free widget. So, you want to keep track of who retweets it, and then at the end you want to pick one of those people as a winner. So there's a couple things that will really limit this, which we're going to get into here in a second. But first, I just want to say that this contest exercise is roughly summed up into about 5 steps. So the first is going to be creating a Twitter app. So, if you've never created one, you'll have to create one. I have the link here. You'll want to go to the Twitter developer docs, and then it's kind of annoying to get through here. If you want to, you can click like apply, and then they have like premium ones, but that's not what you want. You want like the standard API, so we click here. And then we come down through here, and finally it says you have to create an app here. So it's kind of annoying to find this, which is why I have went ahead and just given you a link right here. So this is how you'll sign up for an app. You'll need to have a Twitter account to make this happen, and I'm obviously not signed in on this browser right now. So I've already went and set mine up because I didn't want to have my keys and stuff like that on the screen. But I will sort of explain this to you as we go so you can understand, how you would get that stuff. Specifically in this create a Twitter app step, I have all the sort of pieces of information you want to grab from it. And, consumer key, this is supposed to be secret. I'll have to change it later. So you have consumer key and consumer secret. And, I talk about some other stuff. So if you're using a third-party library, I try to give a little bit more information. In these videos, I'm not going to be doing that. I'm going to be writing this all from scratch. So you're not going to see me, using Anaconda or another one of those Twitter API libraries. That doesn't mean you shouldn't do it. You definitely can. I'm just choosing not to because I want to sort of walk you through that process of reading their docs and figuring out how to authenticate ourselves as we do it. So that's the second step, authenticate with the Twitter API. The third one is going to be using that Twitter API with our authenticated login or whatever it is to basically determine which users have retweeted a specific tweet. So we're going to hit the API endpoint and say, give me a list of all the people who have retweeted this tweet. And then the fourth step, this is something that we need because of 3. We'll get there, or because of a limitation in 3. So when you hit the endpoint in Twitter, let me go back and find it. When you hit this endpoint in Twitter for tweets, if I go to PostRetrieve and engage, click API reference and go here to retweet. I know it's a bunch of links. I have this page here linked directly in the README. But if you read this line, it says it returns a collection, and these fonts, like they're huge, and then there's tiny ones below it. It makes no sense. But returns a collection of the 100 most recent retweets. So the reason I'm pointing this out is if you are running a contest and you were very, very popular on Twitter, there's a chance that you might get more than 100 retweets. So you'll want to make sure that you're polling that tweet every so often. Maybe it's every 15 minutes because you get about 20 retweets every 15 minutes or something. Or maybe you're really, really popular and you need to poll it every 30 seconds or every minute or something. I don't know what your actual use case will be. All I can say is that you'll have to figure out a number that makes sense, and we're just going to try to come up with some sane defaults. I think like every 15 minutes is fine for most people, and you'll keep track of all the people who retweet. So because you only get the 100 most recent ones, you need a way to keep track of other people who have retweeted, before the 100 most recent ones. And that's where we're going to get to step 4, where we're going to open or creating a file that contains a list of unique usernames who have retweeted the tweet. And then what we're going to do is we're going to take all the usernames in that file. We're going to take all the new ones from step 3 when we hit the API. We're going to merge them together. And then we're going to update that file with a new set of, here are all the people who have, unique users who have retweeted this tweet. So with all of this, we get to step 5, which is really the primary goal of this. We can then set a flag or some other option in our application that allows us to basically tell it that we want to pick a winner now. So, the first couple times we run it, we might just update that list of users who have retweeted because the contest isn't over. but at some point the contest will end, and we'll want to have a flag or some other option that you can set that tells it to pick one or maybe more winners, and it'll look through that list of usernames and pick a unique winner or a unique set of winners, and then it'll print them out to the screen. So through this README, this is probably one of the more thorough READMEs I've done. I tried to break down all these steps with a lot of help and guidance. So create a Twitter app, I list like a bunch of different things you'll need to get. For authentication, I linked to the 2 different authentication strategies, and I'm going to be using 2 application-only authentication. But if you use something like Chimera Coder / Anaconda, which is a Twitter API library written in Go, I think it uses something, it asks for a token key and a token secret, I think, which you can get after you create that app. Up here, I'll talk about it. After you create the app and you go to your keys and access tokens tab, there's a link at the bottom where you can actually create one of these, and it basically does most of the OAuth flow for you, and will just give you some keys and stuff like that you can use. At least that's what I'm pretty sure it's doing, but I haven't like verified it. So when it comes to using the Twitter API, I said I linked to the one API endpoint we're going to be using. Again, I'm not using a third-party library, so I'm just going to make my code work for this one endpoint. Now, if you wanted to add more endpoints, I think I have that as a bonus exercise. You could try to make this work for more endpoints. You can take your code and try to move it into its own package. But the first pass of this, I'm going to, mostly just keep it all within the same package, and then we'll move it out a little bit later. I'm doing that because I'm just trying to get something working and, showing you like a crude version of it, and we'll work from there. And then unique usernames, that's basically just opening or creating a file. We've covered a lot of this in past exercises, so it shouldn't be anything too tricky to figure out, especially if you just want to learn how to make files. You can look at some old exercises. And then picking a winner. For this, I'm going to use the rand package and just seed it. And I don't know if that'll make sense to you. But so Go has a Go rand package. It's like math/rand. And you'll have to make sure you seed this. If you do not seed it, you're going to get the exact same winners every time, depending on if your list is in the same order. So you'll want to definitely make sure that you're seeding it correctly, which essentially just means, they showed this where they ran.seed. So you want to change that number to something random. And the best way to get something random is to use like the time.now.unix nano or something like that. Basically get a number from the current time, and then it'll mean that every time you run the program, it'll be sort of random. So the bonus, I said one of them is to turn your code into like an actual API client. And I don't mean support every endpoint. What I really mean is just try to support a couple extra endpoints and see how that would work. And also just try to take your code and move it out of maybe your main package and put it into another package just to sort of see what that process would be like. And, to get an idea for how, how you might make it more usable. And then the second one is to change your program so that instead of being something, the first version we're going to do is a CLI where you have to like run it every 5 minutes or something to update your list. And you might want to change your program so that it uses the code you wrote and it pulls the Twitter API maybe every 10 minutes and it'll update that list. And then you set it so that maybe you provide a flag that says after 2 days, pick a winner. So the program will just keep running on your computer for 2 days. And the real benefit to that is that like if you had a server or something, you could set this up to run on that server and just pick a winner after 2 days. So it would just be a little bit easier. You wouldn't have to worry about like manually running it, especially through the night when you're sleeping and stuff like that. So I think that's everything. Before I go on though, there is one thing I want to mention. This is the first time I've done this, but for this exercise, I actually, let me go to twitch.tv/John Calhoun. For this exercise, I actually have a video here. I did an initial pass on a live stream on Twitch. So if you want to check that out, you can. I don't explain everything quite as well in this because it was really just me experimenting and trying to figure out, is this a reasonable exercise for the time frame? What packages am I going to be using? What challenges might I run into? Because obviously when I do these exercises, I don't mind getting like slightly stuck or something in the middle of something so you can see it. But what I don't want is for me to spend 20 minutes trying to figure out how the docs are, trying to understand the docs or read them on screen. So this was kind of my first pass where I was doing a lot more of that live so that people could see it if they want to see it. And now this exercise is going to be a little bit more curated. It's going to be a little bit more selective in like what I show. And the code from this, these videos are going to be a little bit better than the code that was in the live stream. The live stream it's pretty crappy code. It's pretty bad code is how I'll put it. Mostly just because I wanted to get it working and just make sure I understood the pieces. And then I can use that to sort of design something better for these exercises. And I'm not going to go like above, like go crazy. I'm going to try to keep it sort of like it was my first pass. But, you know, this gave me an idea of what to expect with it. And I'm actually going to try to do that with a lot of the remaining exercises for Gophercises. So I'm going to try to live stream myself doing like an experimental pass on them to verify that, you know, yes, it's something that can be done within an hour or two. Yes, you know, here are the tricky parts that pick out the tricky parts we might need to look at. For instance, in the Twitter one, I had to figure out all the authentication details, and those are things that, you know, they actually went pretty smoothly in the stream, but had they not gone smoothly, I wouldn't have wanted to waste everybody's time watching me spend 20 minutes trying to figure out exactly how their authentication flow works. So, you know, I try to get those kinks ironed out. But sometimes watching me do that in a stream is helpful, so if you want to, definitely check out the live streams. Okay, I'm going to jump right into this exercise. So if you want to code it on your own, here are all the steps, you know, everything you need to sort of get started. But otherwise, jump to the next video. So the first thing we're going to do is create a Twitter app. So you're going to need a Twitter account if you don't have one. I went and created one just for this exercise. I probably won't actively maintain this, which is why the description for this is going to say it's a mostly inactive account. But I have it because you need to have a Twitter account in order to create apps. So I want to be able to do this with you. And then I'm going to go ahead and throw away some of this stuff, you know, some of the keys and stuff like that that you'll see, because I don't want to have those publicly available. So to start, I think I mentioned that you need to go to the apps.twitter.com. And here you'll have this page where you can create a new app. You're going to create one. And in here, we're going to put an app name. So Gophercises exercise 16. Let's put EX16. That's fine. I guess we can just put number 16. It's pretty obvious that they're exercises at this point. Demo application used in the videos. Website is going to be gophercises.com. Yes, I agree to the dev agreement, and I think that's all I need. All right, so I'll create this application, and once this goes through, you'll see that we have you know, your consumer keys here, but it doesn't show you your secret. But what we really need from this page is these 4 URLs. I don't think you're going to actually need all 4 of them, but I would just copy them. They should be the same for everybody, but you know, they're just here, so I definitely suggest grabbing them. You're going to need them. I have them in the description, but I need to open that back up. So yeah, I have all 4 of them here. I think we're going to use 2 of them, but we'll get to that later. The next thing you're going to want to do is go to the keys and access tokens. And here you're going to have a consumer key and a consumer secret key. So if you come back to here, you're going to want to create a JSON file where we can store these. Now, there's 2 reasons for the JSON file. One is just for me. I need to be able to run this without necessarily giving you my key. So I have a sample key here, you know, this keys.json that's committed. It really shouldn't be committed, but it's fine. So basically what I mean by that is I can keep a key that's not committed to GitHub. It's not committed to Git or anything like that. And I can actually fill this in with some values like this. Then I can come back here, get the secret, come fill them in. And then since these aren't committed, or this one is, but if it was one that was somewhere else that wasn't committed, when you go to run the application, you can tell it to read the keys from that file, but then that file won't get committed to your repo. Other developers can use a different file with different keys. So, you know, these are the type of things that you don't want to store in your code, because then they get put in Git history. Anybody who has access to your repository now has access to keys that access your app. And this is just, you know, a bad idea in general, because, you know, say you had to remove somebody from your application. Well, if they still have the old Git repo, they still have your keys. And now they can start doing nefarious things with your, you know, your application keys. So typically you'll see people put them in some sort of file that's not committed. This keys.json is committed, I think. I should have not committed it. So let me see if I can remove that. Git status is what I want. So git rm -cached. All right, so I've deleted it. Now let me add .keys.json. And I'll git add everything, get status. Let me just go ahead and commit. I'm going to do this in master. All right, so the old keys file, or the keys file is probably in the old version, like the old commit history, but that old one had like, data that didn't matter. It was just temporary data. But what we have now is we have this keys.json, which is no longer in Git, and it's being ignored from the git ignore. And so it's not going to be committed with our history, but when we go to run our program, we can read the consumer secret and the consumer key from this and use it to do our application. So what I am going to do is do sample, I'll just do to-do.keys.json, something like that. And I'll put here, fill this in, fill this in, and remove this comment and rename this file to .keys.json. You can't really do comments, so I'm just going to do it like this. Okay, so I'm basically saying that you eventually want to take this file and you're going to want to move it to .keys.json and fill it in with your own information so you have it in your own local repository. So now I'm going to add this, added a keys file. All right, so really what I'm trying to do here, which I know I went in a roundabout way, whenever somebody gets your repository and they go to use your application or whatever, or maybe it's another developer who's adding some features, you're going to want to make it easy for them to get these type of keys files instead of having to figure out what they are on their own. So having like a sample one or a to-do one or something is useful because then they can copy it to their own .keys.json file and start filling in their own information. But this won't be the same information for every developer. Excuse me, they'll have to actually create their own apps and do that stuff. So we have our keys.json. And again, these keys won't work for you because I'm going to delete them when this video is over. But these should work for me. So what we're going to do now is we're going to make sure we have everything else we need. These URLs I already have. I think that's it. All right, so that's it for setting up our application. In the next video, we're going to look at authenticating. So we're not going to quite jump into that yet. That'll be the next video. But this should be good for now. If you really wanted, I guess we could start and do a little bit of code. So let's code main.go. And I'll do package main, func main. I'm going to create a type. Actually, I'm going to create a variable. Keys, struct. Yeah, let's do it this way. It's going to have a key, which is a string. Its JSON is going to be consumer key. And then we're going to have a secret, which is a string. It's going to be JSON consumer secret. And you'll see here that I'm not actually, creating a new type. I'm just, sort of doing this as a, an inline struct here. And I forget the exact correct name for that. But anyway, maybe it's an anonymous struct. But anyway, I'm not creating a type because I don't plan on actually passing this keys struct anywhere. I plan on just using the key and secret values from it. But I want this because it's going to make it easier to read the JSON file. So now I'm going to f, air is os.open, and this will be .keys.json. And later we might have some flags to customize this, but for now I think this is fine. If the error is not equal to nil, panic. Otherwise, decoder is going to be json.new decoder with the file. And I want to defer f.close. So I want to make sure I close that file at some point. And then finally, decode and keys. And we'll print out the keys. So really quickly, I'm just trying to get something that will read that keys.json file and we'll print out those keys. Now let's go run main.go. And that looks to be correct. So if I really want to make sure that that's correct, I'll printf %+v, the new line, and pass in the keys. And you'll see that this has key and secret, so it makes sure I know that each of those fields are set correctly. All right, so let me check out part one. Let's add this. created code or wrote code, parse the let's say consumer keys. All right, so that's everything here for that. In the next video, we'll use these keys to actually authenticate ourselves. So it was nice just to get this out of the way so we have the keys ready. And then in the next video, we can focus on, how do we go about actually connecting to the Twitter API and authenticating. So now that we have, these keys here, the next thing we want to do is figure out how to authenticate. And this is going to be probably one of the longer videos, just because the way we're going to authenticate is all new stuff. So to start, what I would typically do is go to the Twitter API and go to authentication. And then from here, I'm going to application only. And I think I explained this in the, in here as to what they are. If you're using something like Anaconda, let me go ahead and open it so you can see. So Anaconda is going to say your access token, your token secret, your consumer key, consumer secret. So it wants 4 values. If you're using that, what you really need to do is come here to your application, come to the bottom and create an access token. And I believe this basically gives your application OAuth tokens or access tokens to use your specific account. So this would give it access to use the Gophercises account. And that's fine if that's what you want to do, especially if you want to like post tweets and stuff. But I don't need to do that. I just need to, check for retweets and stuff like that right now. So application only authentication should be fine. So I'm going to actually go through that. And I also think it's useful just to sort of read through these docs and figure out how they work. So, it's a good auth flow to figure out. So the basic way this works is, you can read through all this to try to figure it out. But the basic idea is that first we get our consumer key and consumer secret. You're supposed to RFC 170 or 1738 encode, which I think is just URL encoding. Both of these. But we don't actually have to do that. I think they end up churning up the same. But just in case, let's go ahead and say encoded key : equals base64.url encoding dot. Let me go ahead and save this. Do dot encode. I want encode to string. And then I'll pass in the byte slice, which is keys.key. And does this return an error? Nope, okay. So I'm going to do keys.key. And I'm not going to : equals this. And then I'm going to do keys.secret. And then over here, I'll pass in the secret. So, we went ahead and just URL encoded these. I'm going to print them out just to make sure that nothing changed. Sorry about my dog, he's loud. Well, apparently it's not URL encoding, it's some other encoding. What is RFC 1738 encoding? Well, I don't want to mess with this right now. I don't want to waste everybody's time. So if you want to figure that out, you can. But if you read this, you'll notice that it actually says that this doesn't actually do anything right now. It's just in case of future changes. And, if that happens in the future, we can fix our code. But for now, I'm just going to skip that step. So after that, you're supposed to take these two and combine them together in this username : secret or key : secret. And then you base64 encode them as a bearer token. Well, it's not obvious, but if you read through the rest of this and it says an authorization header with the value of basic and then the base64 thing, what this is actually describing is HTTP BasicAuth. So let me see if I can find some examples in here. So you'll see like that's authorization basic, and then there's a encoded value there, or encoded value. Typically what happens with this is, well, basically what I'm going to say is there's no point in us writing all that special code for some of the extra stuff whenever we could literally just go ahead and use the BasicAuth function that is in the HTTP package. So let me go ahead and undo these 2 lines and show you what I mean. So first we're going to go ahead and make a request. HTTP.newRequest. Our method is going to be get, actually I don't know, is it get or post? It's probably post. All right, we're going to post to OAuth2/token. So I think this is one of those URLs from this URL here. I think this is one of those ones that was in our README. Yeah, this first one, this OAuth2/token. So that's one of the ones that we're going to be using. Okay, so we're going to get, the URL is going to be this, and the body. So what do we want? We want strings.newReader, and then I'm going to leave this empty, and we're eventually going to fill this out. Say if error is not equal to nil, panic with the error. Otherwise, we're going to request.set BasicAuth, and this allows us to set basic authentication values for a request that we're about to make. So username is going to be keys.key, password is going to be keys.secret. So, as you can see, we don't have to go through all those steps of setting that header. This is going to handle that all for us because we realized it was BasicAuth. And that's not something everybody's going to get right away. I just knew that because I've used BasicAuth a lot. So it's understandable if you end up doing it yourself. I feel like the doc should have been a little bit more clear that that's what that was. Okay, so we also need to set a content type header. So that's this part. So we're going to do request.header.set content type. The value is going to be this string here. And then finally, we need to make sure the body is this. So we can come back to this strings.newReader is the body. So I'm going to go ahead and replace or put inside of that grant type equals client credentials. And I think that's everything we need for this right now. I think. Oh, this is supposed to be a post, not a get. All right, so now we need to actually make this request. So we're going to need a client. So we'll make an HTTP client, and then we're going to do something like response, error, equals client.do, and we pass in the request. And for those of you who have done things like http.post, and you're wondering why am I not just doing it this way, the main reason is that with the request, you have a lot more options for setting up some stuff. So setting up things like this BasicAuth or headers before you make the request. Whereas you can see with this http.post, we've got limited options. So I find it easier, especially when just experimenting, to make the request, set whatever I need to set with it, and then use this client to actually perform the request. So if the error is not nil, panic with the error. Otherwise, I'm going to io.copy. Destination is going to be standard out. The source is going to be the response.body. And I'm going to defer response.body.close. So we want to make sure we close that response body. So what this io.copy is doing is whatever content is sent back from the response from the web request, I'm going to copy it into standard out, which is just our terminal. So when I run this, I'm actually going to see the entire response just printed out in my terminal. So rather than using strings and reading all that body and then printing out a string, I'm just going to go ahead and do it this way. So if I print this out, you'll see that we use this key and this secret, and then this is the response we got back. So this appears to be an access token as we would expect. If I come down through here, it's showing it. This is like what an access token is going to look like. And if you look at it, you'll notice that it has token type, bearer, access token, and those are the only two fields it has, but this is very, very similar to OAuth. So I'm kind of wondering, if I'm just looking at this the first time, is this an OAuth2 token? Especially because that endpoint we used was OAuth2/token. So, like we're asking for an OAuth2 token, it seems like. So coming down through here, we can look through the rest of this and see how this all works. But knowing that it's an OAuth2 token, what I'd actually prefer to do is to see if we can make that work. Basically see if we can use the OAuth2 package in Go to make our requests work, because that would really just simplify things. So what I'm going to do is do var token OAuth2.token. So I'm just going to set up a token, and then I'm going to try to JSON decode the response body into that token. So decoder is going to be JSON.newDecoder. Response.body is going to be the reader. Then we're going to dec.decode. We're going to do this into the token. We're going to capture any errors and say if the error is not equal to nil, panic. And then we're going to print out the token just to sort of see if that looks correct. Okay, so that token looks to be correct. Like, there's obviously some fields that never got set, but it definitely seems to be JSON decoding correctly. We're still getting these same values from it. So that's looking like we might be able to do that. Then the last thing we're going to do to sort of verify that is to create a new OAuth client and then use that client in order to, actually hit the API. So if I go to OAuth 2 Golang, I can't spell today apparently, but that's okay. I think there's an example. Yes, there's some examples here. So you'll see here in these examples, normally you do a client ID and client secret. I don't really know for sure what those would be. If those would be it's probably our key and our secret is my guess. We've got scopes, which we aren't going to care about. And then we've got these endpoints here. I think those endpoints are used to like refresh and set up other things. I don't know how much of this we actually need, but I'm going to go ahead and just copy it in here right now. So I've got a context.background. Then I'm going to set up my config. The ID is probably going to be key. Well, we can always see if we actually need those, but I think this is going to be key.key or keys.key. And I think the secret is going to be keys.secret. Scopes, we don't need any. They kind of say which permissions you want. And we already have our token at this point, so really we don't need any of that. Honestly, I'm not sure if we need any of this, so we can just try without any of it. See what we get. And then we can do conf.client. Yes, that's what we want. We pass in the context, and then we pass in a token, so we can pass in and token. And then we'll say, so Twitter client is going to be, or T client is going to be this, and then we want to do T client.get. Let's go ahead and get, I want to go ahead and just grab a tweet. So let me grab this one from last week. So I'm going to get the ID from that tweet. I'm going to go ahead and just paste it in here so I have it. And then I'm going to go back to the API for Twitter. And I know we're kind of jumping around a lot, but that's kind of how this tends to work. So we're going to PostRetrieve. I'm basically digging into this retweets API docs, and I'm looking for this URL. So it looks like you get this URL. I don't know if they ever, yeah, right here. So get, there's a URL, and you put an ID in there. So we're going to go ahead and just paste this here. We'll paste it inside of here as the URL. I'm going to take the ID, and I'm going to replace this part. And get is going to give me a response and a body, or a response and an error, sorry. Response, error. And we already have a response and an error up there, so we'll say response 2 with error. If error is not equal to nil, panic. And you can see this code's really getting kind of ugly. We should probably split it into functions at some point. But, again, for now, we're just sort of trying to get stuff working. All right, then I'm at io.copy. Response to sure, os.standard out is where we're going. Response to.body is what we're going to copy there. And I need a colon equals here. Okay. So assuming this worked, this client should it should be a client set up by this OAuth 2 config. And this client should have that token set inside of it so that it uses it to, actually hit the API endpoints. And I don't think we need any of this stuff because as far as I can tell, that token we created doesn't expire. If we look at the data that came back, we only got a token type and an access token. There's not an expiration or anything on that, so it doesn't suggest that it actually expires at any point. So I think that we don't care about the rest of this. We don't need URLs to try to, refresh them. And if we do end up needing them, you'll see here that we have an authorization URL, token URL. We can get these and plug them in there, but I don't think we're going to need them since we're using application authentication and not traditional OAuth. So the reason we did use this OAuth2.config though, is that if you create a client with the OAuth config and you pass it in a token, that one that we parsed earlier, it should attach that to all of your requests for you. So now you don't have to worry about, going through all that work of how do I, attach that token to my header so that I can actually authorize myself. This should do it all for you, which is one of the things I really like about the OAuth 2 package in Go. It makes that really, really easy. So I'm going to go ahead and try this. And it looks like we got a JSON response. It's a big old blob here. So I'm going to try to copy all of this. Well, that's going to take a while. I'm not going to do that. What I'm going to do is I'm going to go up through here. I'm going to get rid of these extra print lines. I think I have another one right there. Get rid of those 2 print lines. And then I'm going to pipe this to response.json. Now I can open up that response.json if it's somewhere in here. For some reason it wasn't showing up in VS Code right away. That's weird. All right, so this looks like a JSON file. I'm going to format the document. And this will, make it look pretty. And this is pretty clearly a nice JSON response. It doesn't look like an error response of any sort. So I think we have this all working. I think we have our application authenticated. I think we're actually hitting that endpoint and making it work. I know I kind of jumped the gun in hitting that endpoint. I think that's the next step. But I feel like you kind of have to hit an endpoint just to to actually make sure your authentication's working. So I'm going to actually change a little bit of this. And then we can do this context background. I can just create inline. I don't actually need the context anymore. So yeah, I think that's good enough to go for now. What we're going to do in the next video is actually look at how to parse the response from this API endpoint and actually get some data from it. But we have our application authenticated. I know that was a lot, and I know that there's a lot of these docs that I kind of skimmed through. I definitely recommend reading some of the docs to figure out, where this stuff came from, why I was doing it, especially the authentication section here. If you look at this and read it, you'll really understand the flow. But basically what it is, the short summarized version is you get your key and your secret, you use them as BasicAuth to this, this OAuth2/token endpoint, and you put this specific body and this specific content type. And then whenever you do that, it will send you back an application-only authentication OAuth token. And then that token shouldn't expire or anything. It should allow you just to continue making API calls until you either invalidate the bearer token, which is down here. They talk about how to invalidate it, or you delete the app or something. Okay, that's it for this one. So now that we have most of our authentication stuff done, what we're going to be doing now is focusing on this third step of using the Twitter API to determine retweeters. And we've already basically gotten this endpoint working. So, we went through and did that with, well, we didn't really do it with the docs, but let me go ahead and open it up. If you do want to read the docs here, you can kind of read through and see that, it returns a collection of the 100 most recent retweets, for the tweet specified by the ID. It shows you the resource URL here. If you scroll down, at some point it shows you get is how you tend to get there. There's also a couple other things that you can do here. So trying to figure out. So there's a couple optional things here that we can add to the the query. I didn't do any of them except for the ID, which is part of the URL. So I didn't limit the count. It has to be less than or equal to 100, and it looks like it defaults to 100 anyway. I'm not sure. It doesn't really seem to say, which is frustrating. But I'm going to assume it defaults to 100. And trim user, I'm not really sure what it does, but I'm not even sure if I care about it. So what I'm actually going to do now is I'm going to come back here and I'm going to do this response.json. And what I'm actually going to try to do here is just figure out what information here do I care about. So I'm looking at this entire JSON blob, and I could try to create a struct in Go that accepts this entire JSON thing. But the truth is we might not need it. So what I tend to do is look at the API and figure out which pieces of information do I care about and just try to parse those out. So looking through here, close that. Well, I'm probably going to want something in here. So I don't care about created at, any of this stuff. So user mentions, that seems to be me, the person who created the tweet. So that doesn't seem right. There is this user section though, and this user section has an ID, and does it have a screen name? Yes, it does. It has a screen name here. So I think this is really what I care about. It's just this user section and the screen name. So I think I can delete almost everything else in here. And then all these fields above it, I don't care about. And then do I need any of these fields below it? Well, to retweet status, I don't think I need any of this. So I'm going to just go ahead and delete all of this. So this is what I'm left with. A really, really small block here that just has a user, and inside of that there's a screen name, and it's got the screen name. And that's the only thing that I actually care about when I'm looking at retweets for a specific tweet. So I'm going to go ahead and just create a type that I can parse this JSON out with. So I'm going to do type retweet response. It's going to be a struct. And here I'm going to put user, which is a struct. Inside of that, there's a screen name, which is a string. And it's a screen name. Is that correct? Yep, it's screen name. And then this username is going to have a JSON of user. Let's go back and make sure that's correct. Yes, it is. All right, so this is what our retweet response looks like. Or it's not the full response though. So if you look, the full response is actually a slice of these users. Well, it's not a slice of the user struct, is it? No, it's a slice of this entire retweet thing. So, we can call it a retweet if we want, I guess. I think that's fine. So we'll call this a retweet. And what we're going to do up here is we're going to try to parse out a slice of retweets. So I'm going to first say var retweets, retweet. And I'm exporting this type. I don't think it really makes a difference because we're in the main package, but eventually that might make sense or it might not. We'll sort of have to see if we pull all of this code into its own package. So we've got this slice of retweets, and then we're going to do a new decoder. So decoder equals json.new decoder. We're going to use the response2.body as the reader for this. And then we're going to do error equals decoder.decode and retweets. If error is not equal to nil, we'll panic. And then we'll print out those retweets. So we're going to actually get rid of this copy. And so I'm hoping this worked. We're going to go test this and see. But basically, we've got this retweet type. And if we look here, the retweet type is really just this section that I've highlighted. And then this full response is actually an array of these. So that's why I'm keeping a slice of retweets here. And then I'm going to decode into that slice and let the JSON package go ahead and handle all the setting this thing up, filling it in with whatever size it needs to be, all of that stuff. The decode function will handle that for us. So assuming this worked, I should be able to run, and I don't want to output this anywhere. And you'll see here that I'm just getting a list of usernames now, which is what I actually wanted. They're obviously nested inside of this retweet type, which is not the exact format we care about, but I think that's fine for the time being. We got all the data we cared about. We can pretty easily pull out the screen names. So looking back at the exercise, what is it that we want to do from here? We want to... So we can ignore pretty much all the other info returned by the API endpoint. All we want is the usernames. So let me go ahead and say, how do we want to do this? Well, let's just go ahead and pull out the usernames. Let's say var usernames. It's going to be a slice of strings. Or say for each retweet in the range of retweets. Usernames equals append. Usernames retweet.user.screenName. Now we'll print out the usernames. Try that. All right, much nicer. All we have is usernames now. And we could even do some really minor optimizations here. We could do something like usernames is make string. We'll set the length to 0 just so we can use append, but we can actually set the capacity here to the length of retweets. So the upside to this is that if we did this first version, append is going to allocate new memory every time it runs out of space when it's adding these new screen names to the username slice. But if we know the exact capacity, so we know this capacity is what we're going to be using, we can set it. which is handy. You can also just set the length and then use an index here to set them. Either way works. I'm just going to leave it like this for the time being. And I think that's enough for now. We could try to clean this code up, but I'd rather just kind of leave it be for the time being. You know, I'd rather just get the whole program working first, and then once it's working, we can come back and try to clean some of this stuff up. But, you know, for now, I think it's completely fine to let it be. Trying to see if there's anything else. Well, I take that back. We can actually pull all this out into a function. Let's just do that. Func, retweeters. And what do we need? We're going to need a client. So that's an http.client. And then we're going to need a tweet ID. So this part here. We'll just do it as a string. And we're going to return a slice of strings. And there's always a chance we can return an error here, so we'll do that. And then we're going to copy all of this code. Actually, not all. We just want this code here. So we'll return usernames nil. If we have an error here, we'll return nil, error. This decoder is new, so we need a colon equal. It's not actually declared inside of this function block. Here, if we have an error, we're going to return nil, error. And this T client, we renamed it to client. So I'm going to make that client. And then we need to build the string correctly. So we'll say URL is going to be thump.sprintf. And we'll put this whole string. And then I'm going to replace the ID part with %s. And then do tweet ID is the value we're going to fill that in with. And then we'll go ahead and pass in that URL. So we can rename this to just be response instead of response2. That'll clean this up a tiny bit. And then I'm trying to see if there's anything else we care about here. Nope, doesn't look like it. Since this whole function contains all the logic we need for parsing this response and everything, you could also take this type and we could just sort of stick it in here. You know, we could take this whole thing and just make this a slice of this struct. Delete this whole piece here. So now we've got this slice of retweets that's just this, you know, anonymized or inline struct, whatever it's called. And the upside of that is that we don't have that type that's being exported or anything. You know, this whole piece is sort of isolated to this function, and we don't have to worry about others somehow relying on it or using it. So we can change it anytime we want without worrying about breaking other people's code. And I think that's a useful thing to do here, especially because we're not actually returning the whole struct or anything. That whole struct is not useful because it's very, very limited. We're just pulling out the piece we care about. Okay, so I'm going to take this and I'm going to try to use it. So we're going to come up here, we're going to create this, and we're going to say usernames, error. Sorry, my dog is just being an idiot today. Retweeters, T client, and we'll use this. Then if the error is not equal to nil, we'll panic. And then we'll print out the usernames. So now let's go run main.go. And it still works. So that looks like a good, good little refactor that didn't do a whole lot. You know, this still isn't the cleanest code in the world, but it definitely cleaned up our main function a tiny bit, and it's going to make it easier to use that retweeters function if we need to. And then long term, we can try to move that into its own type or its own package so that, you know, all the API or the Twitter API specific code is, you know, moved into its own package so we can reuse it if we want. Okay, so that's it for this video. In the next one, what are we doing? We're going to persist unique usernames of retweeters, and we're going to do that in a text file of some sort. So we'll need to figure out what text file to use, and we'll probably start adding flags to our code so that we can actually keep track of, you know, where our keys are coming from, where we're going to be storing the unique usernames, that sort of stuff. Next, we want to look at a way to persist unique usernames. And in doing this, we're going to add another file that we're going to be opening. So I think at this point, it's a good time to add some flags to our code. So we're going to come back here to our code, and just at the very top, we're going to go ahead and try to add some flags to this. I think we'll just go ahead and just create these variables here. Let's do key file, which will be a string, and we'll do users file, which will be a string. And I think those two should be enough for now. And then we're going to go ahead and do flag.stringvar and key file. Name will be key. Value will be .keys.json. So the default value is going to be this keys.json file. And this will be the file where you store your consumer key and secret for the Twitter API. Let's copy this whole thing then and do users file. We'll call this users. And this will be users.csv, I guess. I'll say the file where users who have retweeted the tweet are stored. This will be created if it does not exist. I'm gonna go ahead and just capitalize these and use periods and stuff. And then I guess while we're at it, we can do another one. We can do tweet ID, which will be a string. And we'll do flag.stringvar again. And tweet ID. Tweet, and we'll say the value is going to be empty string if we aren't given one. And we'll probably just have to throw an error if that tweet is not valid. The ID of the tweet you wish to find retweeters of. Okay. I think that's all of them. So we'll do flag.parse. And that should mean that we now have these flags available to us. So now we'll come down through the rest of this code and we'll try to figure out, how to get them all. Now that we've got this keys thing, let's go ahead and pull this all out into a function. So a lot of this video is probably just going to be some refactoring, getting things ready. So I'm going to come down here and I'm going to func, and we'll name it keys. It's going to be key file string. It's going to return key secret and an error. We'll paste all this in. So we're going to create this keys type, or this key struct. It can have the same name, that should be fine. We're going to have the key and secret. We're going to open up this key file, so we'll say key file. If there's an error, we're going to return empty string, error. Otherwise, what we're going to do is return keys.key, keys.secret, and nil. And these two, I guess I could do string, or I can do key, secret, string, then error. And that should be fine. I'm declaring this, that should be fine. All right, so all these returns should be good. So that'll give us our keys. So we're going to come back up here to our code, and we're going to say keys. So we'll say key, secret, error, equals keys. We're going to pass in key file. We'll close all of this stuff. And then next thing we want to do is set up this request that gives us a client, or an HTTP client. So I think what I'm going to do is pull all of this out and return an HTTP client at some point. So all of this code is what I'm going to try to pull out. And what we're going to do is say func Twitter client. I'm not really sure what it's going to return and what it's going to get back, so I'm going to go ahead and just start off by doing, just posting it or pasting this all in here and seeing. Well, it looks like one of our options here is going to be an error. So, and we know we want an http.client. So client and error seem to be our two options for return values. We're going to need a key and a secret, which are strings. So we'll do key and secret here. So up here, if there's an error, we're going to return nil, error. Come down through here, we create the client, we do this request. If there's an error, we're going to return nil, error. And this isn't the client we're returning. This is just the client we're using to get our token. And then once we get the token, we're going to actually create an OAuth config or an OAuth client. And that's what we're going to return here. We want the one that already has the key set up. So we're going to do var token auth2.token. Our decoder is going to be a new decoder. We'll decode everything. And then finally, we will create an auth2.config and use that to create this client. So we'll return this comma nil if all goes well. And then here we're going to return nil comma error if there's an error. I think that's all of it. Okay, so we got Twitter client here. So we can come up here and we can say client is Twitter client key secret. And we're going to need the error here too. And we're going to need some error handling. So if error is not equal to nil, panic with the error. And we'll do if error is not equal to nil, panic with the error. And then we have the usernames, and we're going to pass in just client now. It's not tclient. And for the tweet ID, I can just put this as the sample, and I think that's fine. I will do tweet ID up here, right here. All right. So you can see our main just got really, really simplified. We have a function to get the keys, another function to get the Twitter client, and another one to get all the retweeters with that client. So with all of that, let's go ahead and, oh, it's spell check. That's what's complaining. Let's go ahead and just make sure this works. All right, all the code's working with our refactor. So I'm going to go ahead and just minimize these functions. And I'm just going to put these in the order that I'm actually using them. So I have keys, Twitter client, and retweeters. So what we want to do now is we want to open up this users file, and we want to read in any users who have tweeted there. And then we want to make sure we close that file. So we're going to go ahead and do something like f comma error is going to be os.open. Well, so open here is probably fine, except there's a chance that the file doesn't exist. So I think I have a file here, but let me go ahead and just delete this one. And I'll show you what I mean. Let's say we open users file. If error is not equal to nil, panic. And then otherwise, we'll do something like csv.newReader, pass in the file. And I know this is it's not really a CSV because it's only one column, but it's still a CSV. So we're just going to use it that way. And we'll do r colon equals that, and we'll do lines. Error is r.read. It's read all. And lines declared not used. Okay. Let's print out lines then. Up. All right, there we go. No such file or directory. So that's going to cause us an issue. So what we want to do is go to the OS package. And you know, os.open is for read access only. It's not going to create a file. So I guess there's two ways we could handle this. One is we could just assume that if there's an error, it's probably an error because the file doesn't exist and the users just don't exist. So we don't care about them. You know, we don't care about the existing users because they aren't there. So that's one way to handle it. I think that's reasonable enough. So let's go ahead and do that and say func existing. This is going to take in a users file, which is a string, and it's going to return a slice of users. And I'm going to go ahead and just copy all of this, paste this in here. So we're going to open it. If the error is not equal to nil, we're going to return, let's return, return either nil or an empty. I think it's easier to return an empty slice. So let's return that empty slice. And then we'll come down here and we'll say, we're going to make a new reader. We're going to get the lines. What we want to do here is say users. It's going to be make a string slice. The length of it is going to be the length of lines. And actually, I'm going to say the length is 0 and the capacity is the length of lines. And I'm going to say for each line in the range of lines, users equals append users line 0. And then we're going to return users with nil is, no, we don't have an error. That's right. All right, so all of this can be replaced with something like, well, I forgot to do defer f.close. All right. So that should be everything we need there. Up here, we're going to go ahead and just delete that print line. We're going to say existing colon equals existing. And I know this is weird because we're calling the variable. We'll do X usernames for existing. Exist usernames colon equals existing users file. And then what we're going to do is say, we need to merge these two together. So we're going to go ahead and say for our unique, it's going to be make map of string and struct is the type. And I know that's going to look a little weird. We could use a Boolean or something here, and that would probably be clearer to you. But a struct, an empty struct like this is actually going to take a little bit less memory because we don't actually need anything there. It's just an empty struct. So that's what we're going to do to kind of make this act like a set instead of, an actual map. So this key has to be unique in a map. So this gives us something that's very similar to a unique set, but it's not, we're doing it with a map. I'm going to say for each user in the range of usernames, unique user is going to be struct. So this first part defines the type struct with an empty struct, and the second part's instantiating it with all 0 values or whatever. So that's going to look weird having the two squigglies there next to each other, but that's what we need to do. I'm going to copy all this code and do for each and exist usernames. And then I'm going to do one more for each user in the range of unique. And this one, I don't need the underscore at first because when you range over a map, it's key value. So I don't care about the value. I just want the key. So I don't need to do underscore for the value. It'll just be ignored here. And I'm going to say print out the users. All right, so if we go run this and we don't have that file, we get this unique set of users. That looks to be correct. Okay, cool. Now our last thing to do is to, I guess we could take this code and sort of merge it, or make a function out of it. So let's do func merge a, b, string, and I'll return a string slice. So we're going to take this and say for each user in the range of A, and for each user in the range of B, and then we're going to say var ret, it's going to be a string slice. We'll do ret colon equals make, string slice, length of unique. And we just want to set that as a capacity. It's just easier. And then for each user in the range of unique, ret equals append, ret with unique, ret with user. And then finally we'll return ret. So now that we have this merge function, we can actually just do and I'm going to actually name this new usernames just to we're going to merge new usernames with existing usernames. And then we'll do all usernames. Let's go run this. All right, same idea. It's in a different order, but that's fine. Okay. So now we need to print this out. We need to take all the usernames and we need to print them out, or not print them out. We need to merge them into this users file. We need to go ahead and print them all into it. So lastly, we're going to do something like f, error is going to be os.open, but we already saw that if we do open and the file doesn't exist, it's going to error, and we need this to work this time. We need to create the file if it's not there. But on top of that, we need write access. And when you do os.open, you just get read access. So if I come up here and show you, the very first sample shows you this is for read access only. Oh, sorry. So what we want is a way to open up a file if it exists, and if it doesn't exist, we want to create it. So there's a create function in here, and we could use that, but that still won't give us write when we open up a file. So I think what we're going to look at this is this open file function. And this one's a little bit more confusing because you need a lot more variables here. And it says here, open file is a generalized open call. Most users will use open or create instead. So, it's a little bit different from what we're used to. But what we're going to do is basically what's in this first example, where we're going to open up a file. And then the second part, the flag, is sort of what we're going to be doing with the file, what permissions we need with the file. And then the last part's like the permissions on the file if we create it, I think. And essentially with this is what we want. We want read write, which is RDWR, that's what it stands for. And then we want create, which is, creating the file if it doesn't exist. So we can actually just copy this sample, and we can come back here, and we'll just change this to be users file. And then we'll say if the error is not equal to nil, we're going to panic here. And then what we're going to do is we're going to go through and write all of these lines. We could use the CSV package to do this. I don't see any reason to, given that all of our, well, I guess there could be commas. No, I don't think commas are valid usernames, but let's just go ahead and just create a CSV writer. We'll just be consistent since we already are using the CSV package. So we'll say for each username in the range of all usernames. And we're going to do w.write. And we're going to use username here. So that should get us all these rights. This can return an error, so let's just go ahead and catch it just in case. And then we need to also flush this. So w.flush will make sure that any buffered writes get pushed out. And you'll see this pretty commonly when you look at something like a writer, like a CSV writer. The reason they have it is if you constantly go back and forth to disk and then back to your program, then back to disk to write again, it's going to be pretty slow because we keep opening, accessing that disk and trying to do something on it. Whereas if we buffer a big chunk of writes and then go to disk and just push them all, flush them all at once, it's going to be a little bit more efficient because, we're not constantly going back and forth. We can just flush a big chunk of writes all at once. So what this will probably be doing behind the scenes, I haven't verified, but what I assume it's doing is it's just probably storing some of these writes in memory. And then once it gets so many of them, it goes and writes them all at once. And flush will force it to flush all those writes out so that none of them are in memory. And then lastly, we need to check for any errors. So w.error. So if w.error, I think this just returns an error, right? Yeah. Not equal to nil, panic, actually, let's just do error : equals. Error is not equal to nil. We'll panic with the error. I assume that if you call w.error twice, you're going to get the same error back, but there's always this weird chance that maybe it was coded differently to not do that. I doubt it, but I'm just going to go ahead and grab the return value so I have that. And let's go run this. And let's go ahead and did it open up, or did it create? All right, it has a users.csv. So what I want to do is open up users.csv. And I'm going to delete this and I'm going to put John Calhoun, which I know was not in the list of people who have retweeted. And I'm going to save it. I'm going to close this. And I'm going to run the same code again. And I'm basically just trying to make sure this works with an I didn't want to open that. I'm basically trying to make sure this works when there's an existing username in there. So right now I'm just sort of testing if there's an existing username. Does it work? All right, looks like John Calhoun was in there fine. And it looks like all the others got written correctly. So let's see if it also handles merging. So let's code users.csv. Let's come in here and let's add John Calhoun twice just to see how that gets handled. And let's keep Nitro in here and just see how that gets handled. So we shouldn't ever run into a case where we have duplicate usernames. So I'm pretty sure our code will work, but it's going to be a little bit weird. But I say weird, it's weird in the sense that we shouldn't have ever gotten into this state. But I definitely think having a user already there that we get in our API query is possible. So we want to see that it handles these situations correctly. So let's go ahead and run this. And then let's print out this file. All right, so it looks like Nitro is still here. John Calhoun is only once. So all of this appears to be working correctly. So the last thing I'm going to do before I end this video is I'm going to take this part here, and I'm just going to move it to a function as well. So I'm going to say func write users. We'll just call it write users. I think that's fine. Users file string, and it's going to take in users, which is a slice of strings. I'm going to guess I can only return an error, but I could be wrong. We'll paste this all in, and we'll say return error if there's an error. And we're going to come down here. We're going to do csv.newWriter. I forgot to close this file, looks like, which is unfortunate, but that's okay. All right, so for each username in the range of users, and I can actually just rename this to be user because it's going to be, just simplify our code a little bit. If we have an error here, we're going to return error. And this is going to be a little weird because if we get this error, it could have happened like in the middle of all of our writes. So we don't really know what got written to the users file. So long term, it might make more sense to do something different. For instance, maybe it would make sense to take the CSV writer and write it to some other type of buffer, make sure there's no errors, and then push the whole thing out. That probably doesn't make sense here at all. Or, maybe it makes sense to flush it at some point, or maybe this is, well, I honestly don't know what would make sense. It would kind of depend on how you plan on recovering from that. I'm not expecting any major issues with this, so, I don't expect this to cause an issue. And, I mean, you might want to retry. That might be the other big thing you want to do. Regardless of the error, you just might want to retry writing to the whole users file because you don't want to lose your existing list of users. And that might also be a reason that down the road, maybe it would make sense to not use the same file to read and write. But I think for the time being, it's going to work fine. And then here, we're going to return the error if there was one. And then finally, we're going to return nil if everything went well. All right, so let me go ahead and minimize this. And let's do error equals write users, users file, all usernames. If the error is not equal to nil, panic. All right, let's go run this. And let's cat the users.csv. Everything appears to be working fine. And you'll see that even though John Calhoun isn't being returned by the API, it's staying in that file. So that's kind of what would happen if we were, if we had over 100 retweets and one was, a couple users are in the file, but we're not getting them back from the API call. We don't delete them because they could have retweeted and just they're not in the most recent 100. So it's definitely important to do that. To keep the ones that are there. The downside to some of this is that, essentially, we don't have a good way to verify if somebody unretweeted, but I think that's fine. And we could probably optimize this a little bit if we sorted this list of users, because then we wouldn't have to load every single user into memory. Right now we're taking all usernames into memory by loading the entire file. And if we somehow had 1 million retweets, that might be a good chunk of, it might seem like a lot of memory being used, especially if we're on a minimal system of some sort. So some ways to handle that would basically be to open up the file at that point, basically sort the list of usernames in the file, and then go through the file and insert usernames where they're supposed to be, which is going to be a lot more work, which is why we're not doing it. But, it is something you could do if you decided that this tool was going to be used a lot and you needed it to handle that really, really large use case. Okay, so that's it for this part of the exercise, I believe. We've got the file working. Let me make sure there's nothing else. We're persisting those. Yep, everything's good. The next video, we're going to look at picking a winner, and then we're going to move on to some bonus stuff. Okay, so for this last part, what we're going to be doing is looking at how to pick a winner. So by default, we want our program just to do what it's been doing. We want it to hit the API, update our list of users who have retweeted a tweet, and eventually we're going to get to a point where we want to pick a winner. So the way I'm going to make this flag work for me is that when this flag is set, it's still going to do everything else it does. So this code here is all going to stay the same. That's not supposed to be like that. Yeah, I'm redoing this video because my computer forced an update mid-record, so trying to make sure everything's in the right state. Anyway, let me just go run main.go and make sure this is all working. All right, we got the users.csv, which wasn't there before. That's why I have a change. But anyway, I wanted to do everything it's done before. I wanted to hit the API, figure out who all the existing users are and who the new ones are, merge them all, and write that file. And then finally, once all this is done, what I want my code to do is then pick a winner if that flag is set. So it's going to be something like if pick winner, now we pick the winner. Or maybe if not pick winner, return. Otherwise, we continue on and we pick a winner. So to do this, I'm going to add a pick winner flag. And then for the start, I'm just going to pick one winner. And then later, once we've got that working, I'm going to look at how to pick multiple winners just because I think it's an interesting thing we can look at in the rand package. So I want to go ahead and show you how to do that too. So we're going to do pick winner bool. And then we're going to come down here and do flag.boolvar and pick winner. We'll do winner. Default value is going to be false. And the usage is whether or not to pick a winner of the contest. I think that's fine. So down here, if not pick winner, return. Otherwise, we need to open up this file of existing usernames, and we need to pick one of them. So we're going to say exist usernames equals existing users file. And this is nice because we can reuse this existing function to just get those usernames. And since we've already written it and everything and we've closed it every single time, so this should, yeah, it does close it. Okay, cool. Since we've been closing it and actually handling all the stuff correctly, we can open up the user or the file and get all the usernames from it without having to, redo all that code. So what we're going to do now is we're going to use the random package. So math/rand Golang. And we want to use this to pick a user. And I think we've used random before in another exercise, but let me go ahead and just show you an example. If you're running one of these examples, it's going to give you the same answer every time. So by default, the random package is seeded with 1. If you seed it with something like 42, you'll always get the same results too. You're getting the same exact response every single time. So what we want to do is make that seed more random. So there's different ways to do it. We could just use the random package and just seed it. The problem, it's not going to be a problem with this code. This will actually be completely fine. But if we had like many different packages and they were all using random, there's a chance that these would all be trying to use a global, the seed ends up seeding a global or a package level variable. So it's kind of like having a global variable that all your packages are trying to set, and that could be a little problematic. So what we're going to do is we're going to do a rand.new, which is going to give us a rand.rand. If we look at the random package and look at the index, you'll notice that all of these functions that we have here, things like shuffle and everything else, they're all part of the rand type as well. And the reason this works is that the rand package, as I understand it, let's go look at the source code. Yeah, it has a global rand. So we can come up here and look at it, wherever it is, right here. Well, basically they just create a global random, and then they use that random to go about doing anything, doing all those function level or those package level functions. So, it's not that they're not using the rand type, they're just kind of hiding it from you so you don't have to worry too much about it if that's what you want to do. But I think it's better to generally just create a new random on your own. So we're going to do r:= rand.new. And not that new. I want this one. Then we need a new source, so we'll do rand.new source. And then we need the seed. So this is where we talked about seeding it. That's what we're doing with this. And the seed we're going to use is time.now.unix nano, I think is what I want. All right, so that's going to give us our random. And now what we're going to do is we're going to say n:= r.int_n. And we're going to pass in the length of exist usernames. And what int n does is it says, give me a number between 0 and n, whatever n is. So this n that we're passing in is how many users we have. So let's say we have 5 users. We're saying, give me a number between 0 and 5, but not including 5. So it'll give us 0, 1, 2, 3, or 4. And this is really nice because when you have a slice like this, you can then use that number to just access the index of one of those objects. So with this, we can then say winner is exist usernames n. And now if we go build, we don't have to go build here. I could have just as easily, I could have just as easily done go run main.go and then use the -- help flag, but I'm going to go build because I think that's a little bit clear. So I'll do go build dot and. So I'm going to build and then I'm going to run it. And with the help flag, it's showing me all of these. The only one I actually care about is the winner. And, I might want to change the tweet ID, but in this case, I'm just letting it be the default one. All right, so if I do -win or -winner, you'll see that in this case, it's setting that flag to true, and it's going to pick a winner. So I can just run this a couple different times, and it's going to pick a winner every single time. All right, cool. We have that winner there. So what we want to do now is we want to go ahead and change this to be an integer. And I'm going to choose 0. And we're going to say winners, or maybe num winners, but I'm just going to call it winners. And this is the number of winners to pick for the contest. And this is interesting because we can do int var, not bool var. And we can now just change this to, instead of being a Boolean, it'll always default to 0, which means don't pick any winners. But if we do want to pick a winner, we can pick one. So we're going to say if pick winner is equal to 0, we're going to return. And pick winner is a bad name for this now. So I'm going to, let's rename the symbol to num winners. And then VS Code is going to take some time and rename that. This is not what I wanted it to be. So I'm just going to select them all. Okay, so we have num winners. What we're going to do here is we're going to say we want to pick a certain number of winners. Well, what we could do is do like a for loop here and try to keep picking until we get this number of winners. The problem is every time we pick one at random, we could end up picking a user that's already used. Well, one way to handle that would be to maybe take a user that we picked, move them to the back of the list, and then decrease this n that we pass into int n every time. So that would work. That's one way to handle it. But there's actually an easier way. And if we go back here to the random, I'm going to look for it here. It's called perm. So perm returns a slice of numbers, or essentially it returns a random permutation of the numbers. And what that means is, let me go ahead and show you. Let's comment these two out. r.perm, we'll do length of exist usernames. So you pass in a number and it's going to give you a random permutation of the number 0 through whatever number you passed in, not including the number you passed in. So let's go ahead and go build and run this. And we'll say -winners equals, we'll do 3. So we're not actually picking winners yet, but you'll see here's a random permutation. So it's got 0, then 9, 2, 1. But if you look, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All the numbers are there. And if we run this, we're always going to get a permutation like this. Well, a lot of times you'll use this for things like shuffling or something like that. Like it can be useful for that type of stuff. But where it's also useful is if we wanted to say pick 3 winners, we can get a permutation of all the numbers and then just take the slice of the first however many of these we care about. So if we do a permutation and then do, say, the first 3, we'll get the winners are whoever's at index 5, 1, and 2. So we can actually use this to, make it much easier for us to just quickly get 3 winners. So that's what we're going to do here. We're going to do winners. It's going to be this from 0 to, well, we probably don't want to, we probably need to have an error here. Something that says, basically checks for an out of bounds range, but I'm just going to go ahead and let it be. So winners is going to be these. And I could just say perm is going to be this. Winners is going to be perm. We're going to take the subslice from index 0 to num winners. Then we're going to say for each, we don't want the index, we want the value. So idx in the range of winners. Print line. We'll put 2 spaces. And actually, let's put a tab. And then we'll put, let's do printf. I think printf is going to be easier. And we're going to print out whoever is in exist usernames at the index. And then before all this, we're going to do print line and say the winners are. Okay. So now we should have, exactly that many winners, or we should be getting those exact winners now. So let's go ahead and try this. So we got Nitro, Cool Golang, and Nandotech. And if we keep running this, you'll see that we'll get different ones. And there's going to be some duplicates because we only have like 10 retweets and we're picking 3 of them. So it's likely we're going to have some duplicates. But you'll see here that we're now just getting 3 picked out of there. So this is like a nice, easy way to do that. So the last thing I want to do is move this to a function. So I'm going to go ahead and take this down here, pick winners, and int, and we'll say, we could do this one of 2 ways. We could, let's just pass in the users. And this will return a string slice of the winners. And we're going to paste this here. So we're going to create our random source here. And then we're going to create a permutation out of users, the length of it. Then we're going to do winners is going to be a subslice of that from the number of winners. And then we're going to do, we want to return this. So we'll say var string for each index in the range of winners. We'll say ret equals append, ret with users IDX, return ret, and we could do something here to speed this up just a tiny bit. Length, or this is not going to be length, it's going to be num winners because we know exactly how many we're going to put into this ret. Okay, so that'll pick our winners for us. Now let's go up here and use that. We'll say exist usernames and num winners. And then we'll change this to just be, we don't want this to be IDX. We'll say for each username in the range of winners, just print out that username. Let's go ahead and see how that goes. All right, that appears to be working fine for us. Okay, so that's it for, going about doing all this. This whole printing out part, we might want to move that to a function or something if you really wanted to, but I think it's fine for the time being. Our main is relatively easy to follow now. It's get the keys, get the client, get the retweeters, look at the existing users, merge them with the new users, and then we come down here, and if we need to pick a winner, we pick one. So it's not too complicated to follow the flow of that main. What I think we're going to do in the next video, I'm just going to do one more, I think. One of these bonuses. I'm going to try to turn this code into a relatively decent API that's not going to add any extra endpoints, but I'm just going to try to sort of isolate the stuff that we have and show you how to use the sync.once, which I think is pretty cool. Let me see. It's right here. I'm just going to bring it up and show you. So the sync.once is going to be a way that we can make sure something gets performed exactly once. And we'll see here that whenever we start moving this code into the Twitter code specifically into like its own package, how we can leverage that to sort of simplify, initializing our clients and some of that stuff, but not doing it too early. So we'll do that in the next video. But then after that, I think we're pretty much set with this exercise. So I'm kind of short on time, but I want to quickly try to do a quick video where I show you how I might move the Twitter client to its own package. And then once it's in its own package, how we could then use that to set up a client that would handle a lot of this logic that we have in this application about dealing with Twitter and stuff. We could sort of pull that out into its own thing. And so I guess there's 2 parts to this. One, what we did here at the Twitter client, this function here, is actually not bad. We return an HTTP.client that's already authorized to access whatever endpoints. So at this point, we just have an HTTP client we can mess around with. And that's actually not a bad approach. I think it's actually pretty cool in the sense that, now you're just making regular old HTTP client calls, and as long as you get the endpoints right, you're fine. But there might come a time where you kind of want to just wrap that functionality and not have to think about, all right, what is the endpoint I'm hitting? This part here, we build the URL. So it might make sense to sort of wrap all that into a type. So that's what we're going to be doing here, is mostly trying to get all of this functionality from like Twitter client and retweeters, and that in this, I think keys, no, that one's not going to change. We're basically going to try to get that stuff and move it into its own type. That would be pretty easy to use as an end user. So we're going to start by make their Twitter, which is going to be weird because we have Twitter inside of Twitter, but that's because I want this package to be named Twitter. So in here, we're going to do client.go. We're going to do package Twitter, type client, struct, and inside of here, we're going to have a consumer key, consumer secret. These are both going to be strings. And we're just going to go ahead and just start with that. What we want to do is we want to have a client that we can set up, just set the key and secret, and then later we want to call a function like retweets or retweeters for a specific tweet ID, and we want it to return us just this string error return value. So I'm going to take this retweeters function, and delete it. I'm going to try to move it in here, and we're going to sort of look at what needs to be set here. So this is going to be func c client retweeters, and it's going to take in a tweet ID, a string, and it's going to return a slice of string, which is usernames or an error. I'm going to go ahead and just move this code up. This first part I think can stay exactly the same. We don't have a client though, so we need to figure out how to get that client. Well, we're probably going to need something like a client, which will be an http.client. And we don't need to export that, so we'll say something like this to say that there's some unexported fields here. And I'm not commenting all this, obviously, because I'm just explaining it as I go. So we're going to need to use that client. It's not going to be set up correctly. So the real question here is, how do we want to go about doing that? How do we want to make sure this client is set up correctly? Well, one of the ways you can sort of do that is to create a client method here. And this is going to return an http.client. And what we'd probably want to do in here is you want to name this field. So maybe you want to put an underscore in front of it. I don't love that, but it's probably going to be fine, just to sort of signify that you probably shouldn't be interacting with it directly. And then what we're going to do in here is we're going to do a sync. Well, we don't actually have that yet. So we also need a once. It's going to be a sync.once. And this is really why one of the reasons I wanted to get into this. So a sync.once is a once object that's going to basically make sure we perform an action once. So this is really cool because it allows us to sort of defer setup until later, and then we can verify that it only happens once. So whenever we have a once function, this is the once body here, it'll say once.do, you pass it in some function you want to perform. And what's really, really cool about this is that no matter how many times you queue it up, it will make sure it only happens once, and everything else just doesn't end up executing that function, but it does wait for that function to finish. So, it's a nice way to sort of do setup work that, like, we're going to need to do, like setting up this HTTP client without worrying about, 3 different clients, or 3 different Go routines who might all be using this client. They might all try to make API calls at the same time, and this client might not be set up yet. So we don't want them all trying to set a unique one up on their own, but we also don't want, we don't want anybody to try to make an API call without setting it up in the first place. So what we're going to do here is we're going to c.once.do, and then inside of this, we're going to pass a closure, and this closure is going to be the setup for this client. So what we're basically going to do in here is get this Twitter client. And I'm just going to paste the whole thing in here. I think that's actually fine. I don't need to change anything with it. So I'm going to say c.client is equal to, actually we'll do c error, or not c, temp error are going to be equal to, so this is the only potential downside we have, is that it's possible for this error not to, this to end up being an error. So we probably want to do something like an error up here, but we can do an error here. I think that's fine. I just don't love doing it because it's only a one-time thing. Once it's set up, we're good. I think I'm just going to ignore this error. We're just going to assume that it's set up correctly. And then I'll show you another way to approach this afterwards. So we'll do temp, and we're going to ignore the error. We're going to say equals Twitter client with c.consumer_key and c.consumer_secret. And then we're going to say c._client is equal to temp. And this should be that Twitter client that we went ahead and set up by, we're connecting to we're posting to the API with our credentials. We're going to get the OAuth token, and then we're going to do all that stuff. So that's what's happening inside of this once.do. So it's going to be kind of slow. So we want to make sure it's not done many, many times unnecessarily. And finally, we're going to return c._client. Okay, with all of that, we're going to minimize this. And this is going to be c.client.get. And I think that's most of this code here. Yeah, it is. Okay, so what all of this basically allows us to do is to take this here code, and now we can go ahead and go to our main. We can get rid of this Twitter client in the other part. And what we can do up here is we can do client, it's going to be twitter.client, consumer key, it's going to be keys.key, actually it's just key, consumer, it's going to be secret, and then we're going to do client.retweeters, new usernames, error. All right, this needs to be capitalized, and this is wrong. Okay. All right, so all of our code at this point should work exactly the same. So what's nice about this is that all of this logic for, parsing the response and all of that is sort of isolated to this Twitter package. It's, done inside of here, so we don't have to think too much about it. But on top of that, I'm gonna actually move this function though. But on top of that is the fact that if we started to add other methods that needed to use this client, so maybe we needed a way to look up people who hearted something or liked something or whatever, we could add that sort of thing to this, and it would just be another method on this client. Now, the biggest downside of this right now is this c.once.do that we have could potentially have an error, and we don't really do anything with it. Now, we could also panic in here. I don't love that because, that's something that can happen at runtime, and that's clearly not what we want to happen, especially because this client is useless if that fails. So we essentially have two things that we need to figure out. The first is, do we absolutely need to defer this, this setup stuff? So right now I'm kind of deferring doing it until we actually make our first call. So we set up our client, and at this point, at line 36 in my code right now, it has not actually, hit the API endpoints. It hasn't done any of that. And that's cool because it really means that, we're not doing that unless we actually need to hit those, authorization endpoints. But the downside is that we don't know until this point if we actually have an authentication error. So in this case, it probably actually makes more sense to do something like func new, key, secret, string, and to return a client or an error. And then from here to change these to be consumer key and consumer secret are going to be, well, we don't even need those in there, I don't think. We probably don't need this sync.once anymore. And we can probably just change this to be client. And what's really going to happen here is we're going to say client underscore error is going to be this. If error is not equal to nil, return nil comma error. Otherwise, return and client, where client is going to be client. And we'll put nil as the last argument, get rid of this extra stuff. And now we can get rid of this whole section. And the big reason why I wanted to even show you that big section was because I thought it was cool to see how once works. This was kind of a bad use for it, but you can use it in a lot of other cases where, maybe that wouldn't be the case. There's a lot of initial setup stuff you can defer until later. So now with all of this, the downside of this approach is that the zero value for this client's not very useful. Obviously we can't set those things. So, the key and the secret. So this, making a zero value of this is just not going to be useful. I think that's fine. but it's just something to keep in mind. Now I'm going to go back to the main, and I'm going to say client is going to be twitter.new, and we're going to pass in key secret. I need to put an error here now. And the rest of this continues to work as it was. We've just sort of moved that to its own package. And you know, if you really want to take this further, what I definitely suggest doing is try to find another endpoint. So instead of the retweets, try to find another endpoint that might be useful to hit. Like maybe just getting a single tweet. You know, add one of these that's something like func client tweet, and maybe it takes a tweet ID string, and it returns, you know, some object. Maybe you'll have to create the object. Or you know, maybe this will be get tweet or something. I don't know. But you know, you want some function like that goes and retrieves a tweet for you, and will sort of show you how you can isolate a lot of this logic into this client. You know, so now it becomes really easy to just have this thing where we go around and calling client.retweeters or client.tweet, different stuff like that. And that's really the main benefit to sort of moving it off to its own thing, is that all of this logic we had to write ourselves could be then isolated into a package. You know, that makes it easier. We could continue to do it. You know, maybe we could just do func retweeters, and this takes in an http.client, and it takes in a tweet ID, which is a string, and it could, you know, we could still write our entire package this way, and then the code here would end up looking more like twitter.retweeters client tweet ID. You know, so it's not going to be that much different than what we have here, but I just find it a lot more useful to actually set up this, you know, this client object that sort of handles a lot of that logic for you and isolates it all. And, you know, it also makes it easier because then people don't have to try to pass around these clients all the time unnecessarily. You know, once you set up a client once, you're kind of good to go. But, you know, which of those you use is up to you. So obviously feel free to make that decision. I'm going to go ahead and delete this. Go back here and just make sure this is working. Let me go run main.go. Yep, I got something going wrong. Oh, I know what's going wrong. I call this a client function when it's really just a field now. All right, so I want a cat users.csv, and we have all the users who have been tweeting this. I can pick some winners. All right, this all appears to be working now, so I think we're good. That's it for this exercise. I hope it was helpful to at least see, you know, how to connect to an API, and I hope you did realize that it is very, very easy, especially because the way the JSON package and everything works in Go. The JSON and the OAuth2 package really makes it a breeze to start interacting with APIs. And coming from, you know, experience with some other languages, I find this much, much easier than some of the dynamic languages have been, especially with ensuring type safety and that sort of thing.